The Demon Core Flash. Let me take you to Los Alamos, 1946. The war is over, but the experiments continue. A small, heavy plutonium sphere sits on a metal table. Cold. Silent. But so unstable that scientists literally call it the Demon Core. Enter Louis Slotin, the guy everyone describes as calm, brilliant, and just a tiny bit reckless. Slotin had done this experiment dozens of times. It involved lowering a metal hemisphere over the core and holding it apart with a screwdriver. Yes, a screwdriver. For a nuclear experiment. 7 scientists stand around him, watching. This is supposed to be routine. Quick. Simple. Nothing dramatic. Slotin lowers the hemisphere. The screwdriver slips. Flash. A blue glow fills the room, the unmistakable color of a nuclear reaction. Slotin instantly shouts, "Everyone out!" He rips the hemisphere off the core with his bare hands, shielding the others. He knew exactly what that flash meant. He had absorbed a fatal dose of radiation. And here's the chilling part. Everyone saw the blue flash. Everyone heard the click of metal. Everyone knew what had happened. But the room was dead silent. Slotin died 9 days later. His final act saved 7 others. The Demon Core was never used again. The chlorine gas explosion. A group of chemistry researchers were studying unstable chlorine compounds. The kind that behave nicely until they suddenly decide they don't. One bottle, just one, had been building pressure silently, like an invisible bomb. A student picked it up to move it. The glass cracked. Just a tiny snap. But that was enough. Chlorine gas, bright yellow-green, flooded the room instantly. It spreads low, creeping like fog. It burns your lungs from the inside. Students ran for the door, coughing, gasping. But one researcher stayed just a second too long. By the time help arrived, the room looked like a scene from a disaster film. Broken glass, chemical smoke, sprinklers dripping. And one scientist who never made it out. Dimethyl mercury, the silent killer that slipped through a glove. This one is deceptively simple, and absolutely terrifying. 1996. Dartmouth College again. Dr. Karen Wetterhahn, one of the world's leading toxic metal experts. If anyone knew how to handle dangerous chemicals, it was her. She was transferring dimethyl mercury, a compound so toxic it makes every other poison look like a vitamin gummy. She wore protective gloves, safety glasses, a lab coat. Everything. 2 drops, 2 tiny, clear drops, fell onto her latex glove. No burning. No smell. No warning. But dimethyl mercury doesn't care about your safety gear. It passed straight through the glove. Into her skin. Into her bloodstream. Into her brain. For months she felt fine. But slowly, she began losing speech, vision, memory, coordination. Doctors finally discovered the truth. But it was too late. Her death forced labs around the world to upgrade glove standards. Today, dimethyl mercury is considered so dangerous that most labs don't even touch it. The 100,000-volt arc, one slip, one spark. Our next story starts in a high-voltage electrical lab, 1932. Engineer Vladimir Shorin was testing a massive generator capable of producing 100,000 volts. Basically lightning in a box. The machine was humming. Vibrating. Alive. Shorin leaned in to adjust a wire. A metal tool slipped. And in that microsecond, electricity made a decision. Crack! A lightning arc jumped across the air straight into his chest. Witnesses saw a brilliant flash. Then Shorin collapsed instantly. His death led to modern insulated tools and no-touch protocols still used today. Electricity doesn't give second chances. The Ebola needle slip. One tiny mistake with a deadly virus. Russia, 2004. Inside a level 4 biohazard lab. The kind with airlocks and positive pressure suits. Scientist Antonina Presniakova studied live Ebola samples. She used a needle to transfer the virus. A tiny slip. Barely a scratch. It pierced her glove and skin. She cleaned it. Filed an incident report. Went home. 5 days later. Fever. Headache. Internal bleeding. There was no cure. Her death forced labs worldwide to redesign safety needles and change how high-threat viruses are handled. The Tokaimura criticality. the blue flash seen across a factory. Japan, 1999. At a nuclear fuel plant, 3 workers were mixing a uranium solution by hand. Hand mixing uranium. Let that sink in. 1 pour too many. And the solution instantly went critical. Flash. Bright blue. Silent. Deadly. Technician Hisashi Aoki received a radiation dose so extreme that doctors had no medical guidelines for it. He survived 83 days. But the damage was irreversible. Japan completely rewrote its nuclear safety laws because of this incident. The vacuum chamber incident, when human bodies meet near space pressure. NASA, 1965. Astronaut candidate Jim LeBlanc entered a vacuum test chamber wearing a pressurized suit. Everything was fine. Until a hose disconnected. In seconds, the air pressure dropped almost to zero. A human at that pressure? Your saliva literally boils. Your blood vessels expand. Your consciousness fades in 10 to 15 seconds. LeBlanc collapsed. Technicians scrambled, repressurized the chamber, and saved him. But one technician nearby, exposed to a sudden pressure drop, didn't survive the aftermath. NASA redesigned all vacuum chambers and suit procedures because of this moment. The UCLA chemical fire, a fire that started in thin air. Sherry Sangji, a 23-year-old research assistant at UCLA, was working with terbutylithium, a chemical that ignites the moment it touches air. Literally, it doesn't need a spark. Air is its spark. Sherry pulled back the syringe plunger. Too far. The chemical splashed out. Instant flame. Lab coat on fire. Panic. Screaming. Chaos. Other students rushed in with fire blankets. The flames were put out. But the burns were severe. Sherry passed away 18 days later. For the first time in U.S. history, a professor was criminally charged for a lab accident. This case completely reshaped chemical safety training across America. The thermite experiment that burned through steel. Imagine walking into a laboratory where the air always smells like hot metal and science. That was the everyday world of Dr. Alvin Mercer, a materials scientist obsessed with one thing: making the hottest burning compound ever created. Alvin had spent months developing a new form of superthermite, a mixture so reactive that even military labs refused to test it. But Alvin believed he could control it. And that belief became his fatal flaw. On a Friday morning, Alvin set up what was supposed to be a small-scale ignition test. A few grams of the new compound, placed on a steel plate inside a reinforced test box. But the compound wasn't normal thermite. It didn't burn, it erupted. The moment he triggered the ignition, witnesses said the reaction happened faster than the human eye could follow. Instead of a controlled burn, it became a white-hot explosion of sparks, punching downward through the steel plate like it was paper. The steel table beneath caught fire from pure heat. Then the flooring. Then the wiring. Dr. Alvin tried to shut off the reaction chamber, but the fire moved faster. A chain reaction of superheated metal fragments spread across the room. The temperature was so intense that sensors failed before alarms could activate. By the time the lab's automated system tried to respond, half the room had already collapsed from melting supports. Investigators later discovered the truth. Alvin's mixture reacted several times faster than his calculations predicted. He underestimated it by milliseconds, but those milliseconds decided everything. The official report called it a runaway thermite cascade. Scientists today use his case as a warning. In experimental chemistry, the most dangerous mistake is assuming you're in control.